is an effective geomorphic agent like running water, where it corrodes, transports and deposits the sediments. But it is different from running water in the mode of action and the effect cause. The strength of the wind is independent of the slope, and it can carry materials both upwards and downwards. Wind can whirl the finer particles to greater height, and in desert regions it blows dust storms. Wind erosion is a multi-stage process involving detachment or erosion, transportation and deposition. Each stage plays a crucial role in erosion, relocation and accumulation of particles, especially in arid and semi-arid environments. Detachment and erosional process. Detachment refers to the separation of the soil or sediment particles from the ground surface. It is the first step in wind erosion, and it is initiated when the force exerted by the moving air overcomes the gravitational and the cohesive force holding the particles together. When wind speed reaches a critical threshold velocity, particles begin to vibrate, loosen and eventually lift off. The turbulent eddies and microbursts of air also contribute to particle disturbance. Erosional process occurs in three different processes like deflation, abrasion, attrition. Deflation. In arid and semi-arid regions, when wind remains dry, loose, sand, slit and clay from the land surface is called deflation. The removal of fine material progressively leaves pebbles over deserts as pavements or wrecks. Deflation is more susceptible in dry river courses, beaches and areas of recently formed glacial deposits. In the dry climate, where soil or rock is largely bare of vegetation, large ground surface is subjected to deflation. It does not occur where there is a thick cover of vegetation or the layers of ground. From geomorphological point of view, deflation is more pronounced in the areas of sandstone. There is a selective deflation process by wind. The fine grained particles, those of clay and silt size, are lifted and raised into the air, sometimes to the height of thousands of meters or more. Large particles like gravel fragments or rounded pebbles can be rolled or pushed over the flat ground by strong wind for small distances. When the surface is covered by a mistake of size of particles, the fine sized particles are removed easily, leaving behind the coarse material. Deflation halos or blowouts are formed due to the deflation, which are the shallow depressions, which is a saucer shaped or a tuff shaped landform. The size of the deflation halos varies from few meters to kilometer or more in a diameter, although they may be a few meters deep. Groundwater table is a base level of wind erosion and limits the depth of the deflation. There are numerous examples of deflation hollows. The most known is the Qattara depression in the western part of Egypt, which is nearly 135 meters below sea level. Abrasion. Abrasion is mechanical wear and tear of rock particles by friction, rubbing, grinding or scraping of rocks over the surface. Wind can carry fine particles like dust and sand and hit the rock surface with force. In the places like deserts and semi-desert areas, wind can carry large quantities of sand, dust and fragments which can act as tools of erosion. Soft, less resistant rocks are eroded in time, whereas hard and very resistant rocks are smoothened and polished. The slant blasting effort is greatest within 2 meters of height. The degree of abrasion occurs depends on factors like hardness and angularity of the surface or rock particles, the velocity of wind and the duration of the process. Attrition. Wind attrition refers to the particle on particle collision leading to the gradual breakdown as the particles are lifted and transported by wind. They are repeatedly strike one another during their motion. Over time, with continuous impacts, angular particles become more rounded, larger particles break down into smaller fragments. This transformation increases the proportion of the silt and fine sand in desert region. The process is most effective in sand dunes, desert pavements and dry lake beds where constant wind movement facilitates frequent particle collisions. Transport work of wind differs from other regions of erosion substantially because the direction of the wind is highly variable. Transportation and the movement of sediment particles by wind is carried in several ways. Small particles like fine grain are suspended in air as they are light weighted, whereas heavy and large particles are dragged along the ground surface. Transportation occurs where the particles are loose, formed due to the detachment or erosional process. Wind transportation depends on various factors like particulate size composition, speed of the wind, direction, resistance of the surface, moisture content. Once the soil particles are detached, they are transported by the wind through three major mechanisms depending on particulate size, shape and wind speed. Wind transportation plays a significant role in forming landscape. Wind transportation is interlinked phenomena with many characteristics as the direction of the wind is variable as the direction changes. Large area and great distances are covered. Gradation is followed in transportation where small light particles are transported to farther distances, whereas coarser material are rolled and leaped. There are three main processes of transportation: suspension, saltation, surface creep. Suspension. Suspension involves very fine particles, that is less than 0.15 mm in diameter, being lifted high into the atmosphere and are carried over long distances. It occurs when wind velocity exceeds the threshold for every fine material. When particles are small, they remain airborne for long period of time and can travel hundreds to thousands of kilometers of distance. These particles can reach the altitude of several thousand kilometers and can travel intercontinentally. When concentration of the particles is high, they form dust storms or haze, which reduces visibility and air quality. For example, fine dust from Sahara regularly reaches the Amazon rainforest, fertilizing its soil. Saltation. Saltation is a bouncing and hopping of medium-sized particles along the surface due to the wind force. Wind lifts a particle momentarily. The particles follow a short parabolic trajectory, a few centimeters to a meter, before landing. Upon impact, it dislodges or it kicks the other particles into the air, causing a chain reaction. The process repeats, making saltation the most dominant form of wind-driven transport. Particles travel short horizontal distances, a few meters, and occur close to the surface, less than 1 meter above the ground. Saltation is considered as a common and accounts for most of the sediment transportation in the sandy desert, riverbed, coastal areas. Saltation creates sand ripples and contributes to desert emissions. Surface creep. It refers to slow rolling or the sliding movement of large particles greater than 0.5 mm along the ground driven by wind, and saltation impacts particles transported by saltation collide with larger grains transferring momentum. These large grains roll or creep along the surface but are too heavy to lift. The gradual displacement of coarse material continues rolling movement. It is the slowest form of wind transportation, which is effective for larger and heavier particles that cannot be easily lifted by saltation and suspension. Commonly found in regions with mix of sand, pebble. Best example can be observed in Mojave Desert of USA as moving rocks phenomena.